Hello, welcome to Experience Part 1. This is our second step in the roadmap. Describe how the presented reality is experienced. Let's start with a recap. We said that reality is points that hold an ordered list of numbers. The points' placement in relation to one another is continuous, and in actual reality they form a four-dimensional structure. We will use a model that is a two-dimensional slice from the actual four-dimensional structure. In our description, reality does not change, so the numbers that each point holds are set. We said that reality is governed, and then we continued and divided the ordered list of numbers into two main categories of attributes. The first one is properties, which is equal to saying that a point holds charge. And the second is information about properties of other points, which is equal to saying that the point holds a field. So here is our two-dimensional model. And the continuous lines that have property values are what we would call matter. And from our day-to-day life, we expect them to experience the world. All other points have only field numbers, and from our day-to-day life, we do not expect them to have experiences. The points that only have field values are the emptiness between the matter. We also said that each black line in our diagram is called the world line, and it is an elementary particle. The distinction that makes it a particle is that it has property values. Now, the property values are held by each point on the line, and this means that the characteristics of the point is what defines an elementary particle. So having values in the property placeholders of the ordered list of numbers is the defining characteristic of an elementary particle. And this means that an elementary particle is actually a point in the structure of reality. And this is not only in our model, it's also in the actual four-dimensional reality. The world line just tells us we are talking about the same particle. But actually, the elementary particle is captured by a point. Notice that there is no experience in the described reality. Experience is ongoing change, and the described reality does not change. So from our outside perspective, if we look at the whole of reality, it is a complete structure. It does not change, and therefore it cannot have a feeling of experience. And this means that to incorporate experience into our model, we have to look at it not as a whole, but in a different way. So if we look at this point on a world line, it has an ordered list of numbers, and I divided it into two categories. The black ones are numbers that are connected to charges, and the pink ones are numbers that are connected to fields. So if we imagine us being this point, this is our experience. These numbers, that is what exists, and this is what we experience as this point. Now if we look at another point, then again it has its ordered list of numbers, and this means that if we imagine ourselves being this point, this is our experience, this ordered list of numbers. But from our outside perspective, we can notice a few things. We can notice that the charge numbers are the same, and these 2 points are part of one world line. And we can interpret this from our outside perspective as these 2 points being the same elementary particle. And we can also look at the field numbers, And we can notice that they are different between these 2 points. So from our outside perspective, we can say this is the same elementary particle that just experienced change between this point on the world line to the other point of the world line. But again, from an inside perspective, each point does not know about anything else but its ordered list of numbers, and that is what the point's experience is, this ordered list of numbers. So in order to transfer this interpretation that we just did from our outside perspective, looking at this reality in a certain way, but to transfer this to the inside perspective, we can try and see the way we described the change from our outside perspective, and notice that actual world experience of ongoing change involves the feeling of existing at one point of a world line, knowing the numbers of other points below us on the world line, the ability to compare numbers, and finally moving the feeling of existence up along the points of the world line. If these 4 statements exist, then we can have actual world experience from our inside perspective. Now notice that at first glance, an elementary particle world line seems not to possess clauses 2 to 4. So an elementary particle does exist at one point, but it doesn't seem to have any knowledge about any other points below it on the world line, and it doesn't seem to have the ability to compare the numbers in order to understand if change happened or not. And we do not have a mechanism for moving the feeling from one point to the other. However, the fact that reality is a complete thing means that all points depend on each other. So reality is a solution to the rules that created it. And because they are creating rules, we can say that a point's information is determined by other points. And that means that they are actually all connected. All the points are connected to each other. So let's try and get a sense of elementary particles processing information about change. And for that, we imagine a reality with only 2 elementary particles. The world lines of these 2 elementary particles constantly change their trajectory. Alice creates a field which affects the trajectory of Bob, and Bob creates a field that affects the trajectory of Alice's world line. Notice that this is a back and forth exchange because the change of the trajectory of Bob affects how it will affect the trajectory of Alice and vice versa. So we can say that each point on the world line has information on another point, and that point has information on another point, and that point has information on another point, so they are basically all connected to each other. Let's start by looking at this point on Bob. It has its ordered list of numbers, and it has its charge numbers, which means that it creates a field along this information track over here. And that means that if we look at this point on Alice's world line, it has its ordered list of numbers, and the field numbers over here are correlated to these charge numbers on Bob at this point. So there is a connection between this point on Bob and this point on Alice. The charge values at this point on Bob determine the field values at this point on Alice. Now these field numbers act on Alice's charge values, these numbers over here, by determining the trajectory of its word line to the next point. So this is the next point, and the location of this point is determined by these field numbers acting on the charge values of Alice. And this means that we can say that this point on Bob is connected also to this point on Alice, because it affects its location. And as this point affects the next point on the word line, we can basically say that this point on Bob affects all the points on Alice's word line from here on. Now let's continue. And this point on Alice has its charge values, which means it creates a field along this information track. So if we look at this point on Bob, the field numbers in its ordered list of numbers are affected by this point on Alice, which is affected by this point on Bob. And if we look at the next point over here, again, it creates a field, which means that if we look at this point on Bob, the orange point on Bob over here, the field value numbers at this ordered list of numbers are affected by this point on Alice. And as we said before, this point of Alice is affected by this point on Bob. This means that we can say that this point affects in a roundabout way this point on Bob itself. And this means that if we look at the field numbers over here, there is some information in these numbers about this point on Bob. So we can say that this point on Bob has information about another point on Bob that is below it on its word line. And this also works for Alice, so we can go through the same procedure. And if we look at the point on Alice's word line, we can say that in its values of its ordered list of numbers, there is information about points below it on the word line. But notice that the information about other points is hidden from plain sight. So by just looking at the field numbers of one point, we cannot really pry out the information about other points in our world line. So we cannot really build from one point the whole outside perspective view that we have of how the trajectories look and what are the charge values of each world line. To continue, let's try to see how a point can compare things. So if you remember, we said that the electric field at the elementary particle point that we examine, and we'll use a point on the word line called Alice, is a combination of all the field values traveling along all information tracks. And the combination of all fields gives us a value and a direction. Now, the direction is a combination of all the directions of the information tracks that the fields travel along, but this combination is weighted. So the information track with a higher field value has more weight to its direction. When we look at this point on Alice, the green point over here, it is affected by two fields. One is created by Jack and one by Bob. Let's start with this point on Jack over here. It creates a field along this information track, and if the electrical charge of Alice and the source electrical charge and Jack are of the same sign, then it wants to change Alice's word line in this manner along the information track it was created by. And if we look now at this point on Bob, it creates a field along this information track. And again, we say the electrical charges are of the same sign. So it wants to change Alice's trajectory along this information track. And the final direction of the field at this point is a combination of them according to their weights. So the field value created by Bob at this point is stronger than the field value created by Jack at this point, and therefore the field final direction tends towards the direction that Bob wants to change the trajectory. Now, when you think of it, this adding up of the fields is actually a comparison. So the way of adding up fields from a number of information tracks puts some information about the relation between them in the result. Because the result depends on these two fields separately, it has information about the relation between these two fields. And therefore we can say it is comparing these two fields one to the other. But again, this information is a bit hidden out of sight. It's not readily available when we look at the numbers of the field at a point. So let's see how can we uncover the hidden information that is present in the information in elementary particle holes. And for that, let us look at two elementary particles that are at a steady balance. And by steady we mean the word line configuration is such that the word lines follow the same pattern, one in relation to the other. So there is a constant balance between the change in the word line trajectory and the other particle's field. Now notice that such a configuration needs more dimensions than in our model. Nonetheless, we will just say these two particles are in a steady state and see if we can still learn something with the constraints of our model. So if we look at these two word lines, we'll call them Alice1 and Alice2. They keep the same relationship between them. And as we said, this could not really happen in our two-dimensional model because each point on Alice1 creates a field on Alice2 which wants to change its trajectory, and vice versa, which means that these two lines want to move away from each other or come closer to each other. But we know there are two more dimensions in play. So what we can think about is these two lines representing two spirals with a common axis. So the field of Alice1 changes the trajectory of Alice2 in these two extra dimensions, and the same for Alice2. Its field changes the trajectory of Alice1 in these two extra dimensions, and this allows them to keep a steady relation between them. This means that if we look along the world line of Alice1, we can find points that have the same ordered lists of numbers. And the same goes for points on Alice2. So what we have is repeating cycles that maintain the relationships between these two world lines. So there is some information in the fact that the relationship between these two world lines is steady. And this means that if we look at another world line that is not part of this steady configuration, then when it affects Alice, the information about this effect is captured within the steadiness. So if we look at this point on LS1, it has some information about the effect of this point of Jack. And if we look at this point over here, it will again affect this same point on LS1. So at this point, we have a comparison between these 2 points on Jack. So having a thing made of a few elementary particles in a steady state allows us to compare information to the steady state, and thus more easily separate the outside changes from the total information. Okay, so that gives us a sense of how a point can experience change. So you got to feel how the information that allows us to experience change actually exists in the numbers of an individual point. However, we cannot find in our description of reality a mechanism for moving the experience from point to point along the world line. So the last statement that we said that is necessary for actual world experience, it stays an open question. But now if we go back for a minute to our other way of describing reality, the changing reality description, then in that case, changing reality solves this question by stating that only one point from the world line exists, and this one point reality is in constant movement. Now, although this is a statement, so there is no real explanation here, it does seem to offer us a mechanism for the ongoing part of the actual world experience. But I want to caution you that ongoing change in our day-to-day life is captured by the term time. So we are tempted to say that the movement of reality, of this changing reality, is time. And this means that time exists. However, Einstein's relativity abolishes a universal time. So there is some contradiction with observations that do not allow us to assume there is a universal time that everybody agrees on. And this means that the movement of reality is not time as we know it, rather it is change, which means that what exists is change. Going back to our unchanging reality description, let's try to focus on what information we have in the field numbers of a point. So the field value numbers of this point on Alice are affected by a few things. They are affected by the charge numbers of Jack at this point and the charge numbers of Bob at this point. And they are also affected by the distance along the information tracks between this point on Bob and this point on Alice, and this point on Jack and this point on Alice. So the information and elementary particle holds, which are the field values at the point we are looking at, in our case we looked at Alice, is a summation of effects of all the other elementary particles, and in our case, Jack and Bob. And as we showed, the field numbers held by our point are affected by other elementary particles' property numbers, and the property numbers define what type of elementary particle the world line is, so they tell us who is around us, in our case Jack and Bob. And the second part is the location along the information tracks leading to our point. And this tells us what is the world line's relationship in respect to us. Now, if we combine this knowledge with actual world experience of ongoing change, we can summarize and say that an elementary particle knows about the behavior of other elementary particles in relation to its world line. So the knowledge that Alice has about reality is of the existence of Bob and Jack and the relation between its world line to their world lines. It does not know about the trajectory of its world line in relation to reality. It does not see reality. It only has knowledge about other elementary particles and the relationship between it and their world lines. Okay, let's summarize. We said that actual world experience, which is ongoing change, is not a basic feature of reality. Actual world experience is in part a result of a stable configuration of a few elementary particles, and that means that the actual world experience is in the stable configuration of a few elementary particles, and we said that a few elementary particles together are called a thing. So actual world experience is not something that is part of reality itself. It arises within things. Now the thing's experience is of other elementary particles that are not a part of it. That is what is compared. That is what is changing. So because a thing is steady, and therefore in a matter is not changing, it feels changes from an outside source. And in a practical manner, a thing experiences the change of other things in relation to it, point by point along its world line. And finally, we said that the movement from the experience of one point on the world line to another is not explained for our model, the model of unchanging reality. Okay, in the next video, we'll continue exploring how we experience reality and try to move from describing the experience of elementary particles to more of our actual world day-to-day experiences.